Hello people, my name is Sn0wF0x and today we are going to do the second half of the Nmap room from Tryhackme. As you might remember from part 1, Nmap is one of the most, if not the most, used tool for enumeration of networks and servers. And the last time we discussed the switches, the introduction, what Nmap is and what it does. This time we are going to discuss the scan types of Nmap. So without further ado, we go into this, but first of all, we need to take a look at this. This is a so-called three-way TCP handshake. The Sn, Synac and Ag. This is the entire handshake that is the fundamental of networking. So as you might see here, it's something funny with Frank Sinatra. This is actually something that really helped me learning this. I am not quite that good if it's like I can't talk today. It's not that good like I would have it to, but yeah. So let's see. When port scanning with Nmap, there are three basic scan types. These are TCP connect scans -ST, Sn half open scans -SS, UDP scans -SU. Additionally, there are several less common port scan types. Some of them will also cover, albeit in less detail. These are TCP null scans, TCP fin scans, and TCP XMS scans. Most of these, with an exception of UDP scans, are used for similar purposes. So, before we continue, most, if not all of these scan types are related to this model. Some are going to break in the middle of this, others are going to modify this thing a little bit. This is because we want to not let our opponent or our target machine know what we are going to do. So there are several ways to actually avoid the target system to register that we are up to do something. So, completed. TCP connect scans. To understand the TCP connect scans, it's important that you're comfortable with the three-way TCP handshake. That is this one here, the Synac scan. A brief recap: the three-way handshake consists of three stages. First, the connection terminal, our attacking machine is in this instance, sends a TCP request to the target server with the SYN flag. Yep, this one, client to targets. The server then acknowledges this packet with TCP response containing the SYN flag as well as the SYNAC flag. Finally, our terminal completes the handshake by sending a TCP request with the AG flag set. So, synchronized acknowledge, and last of all, the acknowledge. And yeah. Well, as the name suggests, a TCP connect works by performing the three-way handshake with each target port in turn. In other words, Nmap tries to connect to each specific TCP port and determines whether the service is opened by the response it receives. For example, if a port is closed, RFC 793 states that if the connection does not exist, then a reset is sent in response to any incoming segments except another reset. In particular, SYNs addressed to a non-existing connection are rejected by this means. In other words, if Nmap sends a TCP request with the SYN flag to a closed port, the target will respond with a TCP packet with the reset flag set. By this response, Nmap can establish that the port is closed. Like we have here, client server, SYN, reset, if it's closed. So then we don't get the entire three-way handshake, which is quite obvious because if it's closed, it can't respond. So you get a reset, stands for RST. If, however, the request is sent to an open port, the target will respond with a TCP packet with the SYNAC flags. Nmap then marks the port as being open and completes the handshake by sending TCP with the exit. So basically just what happens if the port is closed, and then you will get another flag back. So So, many firewalls are configured to simply drop incoming packages. Nmap sends a TCP SYN request and receives nothing back. This indicates that the port is being protected by a firewall and thus the port is considered to be filtered. This is something else. It's different if the port is closed or blocked. This is something completely different in the world of networking. Let's say it's very easy to configure a firewall to respond with a reset TCP packet. For example, in IP tables for Linux, a simple version of the command would be as follows. And then you have the comment. This makes it extremely difficult, if not impossible, to get an accurate reading of the targets. So, which RFC defines the appropriate behavior of the TCP protocol? We just saw this. It's this one. RFC 793. It rhymes a bit. Then, if a port is closed, which flag should the server send back to indicate this? Well, we just learned this. It's the reset flag. If the port is closed, the reset flag will be sent and you know it's closed. Next one, the synth scans. As with TCP scans, synth scans are used to scan the TCP port range of a target or targets. However, the two scan types work slightly different. Synth scans are sometimes referred to half-open scans or stealth scans. This is what I meant when I said that at some point it's possible to make a scan more or less invisible for the target network. And this is something you will need for Tryhackme later on. In some cases you will need this. There are, as far as I remember, some challenges which requires this scan type. Where TCP scans before a full 3 handshake with the target, synth scans send back an RST TCP packet after receiving a SYN ACK from the server. This prevents the server from repeatedly trying to make the request. In other words, the sequence for scanning an open port looks like this. You see, SYN ACK, reset. There's a variety of advantages for us as hackers. It can be used to bypass older intrusion systems as they are looking out for a full 3-way handshake. This is often no longer the case with modern IDE solutions. It is for the reason that synth scans are still frequently referred to as stealth scans. Synth scans are often not logged by applications listening on open ports. A standard practice is to log a connection once it's fully established. Again, this plays into the ideas of synth scans being stealthy. There are, however, a couple of disadvantages to synth scans, namely, they require pseudo permissions. This is important. You need higher privileges for this. Obviously, why? Unstable services are sometimes brought down by synth scans, which could be problematic if a client has provided a production environment for the test. All in all, the pros outweigh the cons. For this reason, synth scans are the default scans used by Nmap if run with sudo permissions. If run without sudo, Nmap defaults to TCP connect scan we saw in the previous task. This is important because you will, if you use Nmap for a longer time being, then you will switch some flags from time to time. And you need to know what are the default settings, because sometimes if stuff don't work, you might need the default settings. When using a synth scan to identify closed and filtered ports, the exact same rules as TCP connect scan apply. If a port is closed, then the server responds with a reset TCP packet. If the port is filtered by a firewall, then the TCP scan packet is either dropped or spoofed with a TCP reset. In this regard, the two scans are identical. The big difference is how they can handle open ports. So, there are two other names for a synth scan. What are they? We just had this. It's half open and stealth. So, can Nmap use a synth scan without sudo permission? Nope, it can't. Alright, next one. I think we do this in 3 parts this room. So task 10 to 15 will be in the 3rd part of this, because it's, like I said, a really huge room. UDP scan. So I hope you remember what was the main difference between TCP and UDP. TCP is for accuracy, if I remember correctly. TCP is for accuracy, which means you want the packages to actually go to the target. This is what you want. You want the packages, importantly, being fine at the other end of the connection. UDP doesn't require this. It's for speed. You don't give a damn how much packages are actually made it, as long as some, if not the most, made it. This is why TCP is for downloads and UDP is for streaming. Because in streaming it doesn't really matter how many of those are. In worst case you get fragmented views, but when you download something you want to have all the data. And this only works with TCP. This is what more or less stands here. Unlike TCP, UDP's connections are stateless. This means rather than initiating a connection with back and forth handshake, UDP connections rely on sending packets to a target port and essentially hope that they make it. This makes UDP superb for connections which rely on speed over quality, like video sharing. But the lack of acknowledgement makes UDP significantly more difficult and much slower to scan. The switch for an Nmap UDP scan is -SU. When a package is sent to an open UDP port, there should be no response. When this happens, Nmap refers to the port as being open filtered. In other words, it's suspected the port is open, but it could be firewalled. If it gets an UDP response, which is very unusual, then the port is marked as open. More commonly, there's no response, in which case the request is sent a second time to double check. If there's then a response, then the port is being marked open filtered and Nmap moves on. When a packet is sent to a closed UDP port, the target should respond with an ICMP ping package containing a message that the port is unreachable. This clearly identifies closed port, which Nmap marks as such and moves on. Due to the difficulty in identifying whether a UDP port is actually open, UDP scans tend to be incredibly slow in comparison to the various TCP scans in the region of 20 minutes to scan the first 1000 ports with a good connection. For this reason, it's usually good practice to run an Nmap scan with -- top ports enabled. For example, scanning with Nmap -U top ports 20 will scan the top 20 most commonly used UDP ports, resulting in a much more acceptable scan time. When scanning UDP ports, Nmap usually sends completely empty requests, just raw UDP packages. That said, for ports which are usually occupied by well-known services, it will instead send a protocol-specified payload which is more likely to elicit a response from which a more accurate results can be drawn. This was quite a lot of text. If a UDP port doesn't respond to Nmap scan, what will it be marked as? You are right. Open filtered. Open filtered. When a UDP port is closed by convention, the target should send a back port unreachable message. What protocol would it use to do so? We just learned this in this exact sentence. It's an protocol, ICMP. So let's go to the last two questions for today. Null, fin, and XMS scans. We will roughly not do this much because, Okay. Null, fin, and XMS TCP port scans are less commonly used than any of the others we've covered already, so we will not go into a huge amount of depth here. All three are interlinked and are used primarily as they tend to be stealthier, relatively speaking, than a SYN stealth scan, beginning with null scans. As the name suggests, null scans are when TCP requests is sent with no flag set at all. As per RFC, the target host should respond with a reset if the port is closed. So, we're going to remember, null scans means the TCP request is sent with no flags set at all, and the target should respond with a reset if the port is closed. Fin scans work in almost identical fashion. However, instead of sending a completely empty packet, a request is sent with the fin flag, usually used to gracefully close an active connection. Once again, Nmap expects a reset if the port is closed. As with the other two scans in this class, XMS sent a malformed TCP packet and expects a response for closed ports. It's referred to as an XMS scan as the flag that it sets gives the appearance of a blinking Christmas tree when viewed in a packet capture in Wireshark. Sadly, I can't show you this. Sadly. The expected response for open ports with the scans int is also identical and is very similar of that of a UDP scan. If the port is open, there is no response to the malformed package. Unfortunately, as with our open UDP ports, that is also an expected behavior if the port is protected by a firewall. So null, find, and XMS scans will only identify ports as being open, filtered, closed, or filtered. If a port is identified as filtered with one of these scans, then it's usually because the target has responded with an ICMP unreachable package. Whew. Which one of these three scans uses the URG flag? Let's see. Which uses this? Could it be the XMS scans? We don't know. Let's see. Oh, wait a second. Hello, I want to type. Laptop, would you please let me type? Yep. As you might question why I know this, it's right here. URG. Why are null, fins, and XMS scans generally used? So the answer to this is because of something quite easy. I'm in the wrong tab. So it's because of firewall evasion. This is the reason why it's, yeah. So, which common OS may respond to a null fin XMS scan with a reset for every port? I guess you can already think about it, which one it might be. Yep. ICMP network scanning. This is something that really made me struggle sometimes because I am quite bad at math. On first connection to a net target network in a black box assignment, our first object is to obtain a map of the network structure. In other words, we want to see which IP address contains active hosts and which do not. One way to do this is by using Nmap to perform a so-called ping sweep. This is exactly as the name suggests. Nmap sends an ICMP packet to each possible IP address for the specified network. When it receives a response, it makes the IP address that responds as being alive. For some reason, we'll see in later tasks, this is not always accurate. However, it can provide something of a baseline and thus is worth covering. To perform a ping sweep, we use -SN switch in conjunction with IP ranges, which can be specified with either a hyphen or CDY. It's okay, Sn0wF0x, you can read this. CIDR notation. If we could scan the 192.168.0x network using Nmap -N and then the IP, or this one. The -SN switch tells Nmap to not scan any ports, forcing it to rely primarily on ICMP echo packages or ARB requests on a local network if run with sudo or directly as the root user to identify targets. In addition to the ICMP echo request, the SN switch will also cause Nmap to send a TCP SYN packet to port 443 or the target, as well as TCP ECK packet for port 80 of the targets. This was a hell lot of text. So, how would you perform a ping sweep on the 172.60.xx network? To be honest, I had to Google this question because I really suck at this and I haven't understood it quite yet. So it's this answer. And that's it for today's video. We had a lot of text, but it's the most important room, so please check it out if you haven't already. It's much to learn, but you will need to learn everything of this because Nmap is one of the most important rooms in your entire career in the cybersecurity business, and you will need it. So if you have critics or something else, just put them in the comments. See you in the next video. Bye bye.